Earth's crust and plates. Hi, I'm Miss Susan. What's inside our amazing planet Earth? Gnomes and trolls? A gloomy underworld of ghosts? A dragon ready to hatch? Let's study geology to learn about the crust and plates on the outside of Earth and what is deeper down inside it. Geo means Earth, ology, studying or learning about. Think, does Earth have a crust? Crust, a hard outer covering of something. All of the outside of this bread is the crust. It's harder than the bread inside. The pie crust goes all around the outside of the pie, and the apples are on the inside. But how can Earth have a crust if it's covered with oceans? Earth's crust is all the land at the bottom of the oceans and also all the land on Earth. It's hard, made of different kinds of rock. Oceanic crust is at the bottom of the oceans. Continental crust is all the rest of the land, which is above water. Underneath the crust is a big layer called the mantle. It's made of rock, but it is so hot that it is soft like clay or mud. When the mantle melts to a liquid, it's called magma. It's the stuff that comes out of volcanoes. The crust floats on top of the mantle and slides around slowly. The crust is cracked into pieces that fit together like a puzzle. These pieces are called tectonic plates. Continental drift. The continents are moving. The continents are part of the plates. So when the plate moves, so does the continent. The plates push against each other, moving very slowly. Since they are all right next to each other, the edge of one plate can slide under the plate next to it. The plates only move about 1 or 2 centimeters per year, but over millions of years they've moved a lot. The Indian plate moved faster than the other plates, so when it bumped into Asia, there was so much pushing force that the Himalayan mountains formed. These maps show where the continents used to be millions of years ago. The pink lines on this map show the edges of the plates and also show if they are pulling apart from each other, pushing together, or sliding sideways. The green arrows show which direction the plates are moving. Subduction, pushing under, divergent, pulling apart. Convergent plates, convergent, coming together, subduction, going down under. When an oceanic plate pushes toward a continental plate, it creates a mountain range with many volcanoes. The oceanic plate gets squeezed down under, subducted. Then it melts back into the mantle. This motion can make some of the melted rock, magma, rise up into volcanoes. This is what is happening in South America. The Pacific plate is going under the South American plate, making the Andes Mountains. A trench is a very long, low place. There is a trench in the ocean where the plate is going down. Convergent continental plates. When continental plates come together, they make the biggest mountains. The Indian plate collided with the Eurasian plate 10 million years ago. Two plates can both turn upward to make mountains, or one can go under the other. The Indian plate is still subducting under Eurasia today, making the Himalayas ever taller. They grow about 1 centimeter higher every year. Divergent plates. Divergent, moving away from each other. Sometimes plates are diverging, like the North and South American plates, which are moving away from the African and European plates. Then a long crack called a rift opens up. Magma pushes up through the rift. This made a line of volcanoes underwater in the Atlantic Ocean called the Mid-Atlantic Ridge. When the magma hits the ocean water, it cools off, hardening into new crust. Every time more magma comes up, the ridge gets higher. If a volcano gets so high that it comes above the ocean, then it's an island. Wow, I'd love to see this. Underwater volcano. People can't go down there, but a robot submarine took this picture and a video.
On planet Earth, this is a process happening all the time, yet we have never seen it happening quite this way. The ocean floors are formed almost exclusively by volcanic activity.
That underwater volcano was along the Mid-Atlantic Ridge. If you look at the map on the left, you can see it, that black line, and towards the top you can see an island, Iceland, next to Greenland. Well, that volcanic island of Iceland is right on top of the Mid-Atlantic Ridge. Iceland is on that crack between the North American plate and the Eurasian plate. The plates are moving apart 3 centimeters each year. This means Iceland is getting a tiny bit bigger each year. It will take 1,000,000 years to add 25 kilometers. I visited there in 2016. You can see me at the picture on the right. The rocks look a little different on each side of the rift. There's a large lake over part of the rift that was formed during volcanic activity. Sometimes plates slowly break apart into new plates. The Great Rift Valley in Africa is where the African plate is splitting apart, but it will take millions of years before it moves into the ocean. So many of the volcanoes on Earth are along all sides of the Pacific plate that it's called the Ring of Fire. There are also more earthquakes along the edges of plates than in the middle. But I wonder why the Hawaiian volcanoes are in the middle of the Pacific plate, not at the sides. The Hawaiian Islands are in the middle of the plate. There's a hot spot where the magma breaks through the crust to make a volcano. If the volcano grows tall enough, it rises above the ocean to become an island. Then, as the plate moves to the side, that tall volcano moves with it, and then a new volcano forms over that same old hot spot. This is why islands form in a chain. This volcano in Hawaii, Mount Kilauea, erupted all the time without stopping for 35 years, from 1983 until 2018. It still erupts, but not every day. It is truly amazing that our Earth is filled with hot melted rock and that the continents are moving and changing right under our feet. Thanks for watching. If you enjoyed learning about the Earth, please like and subscribe to see more videos. You might also like to see my website, pathwaytoenglish.com. Bye.